Dear student, you can see the automated injectable liquid filling line, and this video you can see the different vials which are automatically filled. Foreign vial rejection system. You can see the movement of the sensor per vial counting. As the vials are counting using the sensor. You can see on the left side the sensor and the movement of the sensor. Vial vapor is there. And this one is the sensor. Immediate for the counting of the vials passing this particular sensor. And this area is outer wash with water. You can see at the label that outer wash with water and outer wash with air. This is the outer of the vials is washed with the water and air. In that particular area, to which it is passed. You can see the movement of the vials, this particular machine. And this is the wash of air and washing of the water. The outer of the vials. And after this washing, the vials are further subjected to that area. The moment you can see after the washing through air and water, these are moved to the other part of the machine. You can see the movement of the vials. It is Durlin conveyor for vial transfer. Durlin conveyor for vial transfer. You can see the movement, ups and down movement of that filling areas. You can see the filling. No vial, then no filling. When the vial is there and filling is made, and after that filling, you can see the caps. Now caps says rejection track for no rubber stopper on vial, and vial counting sensor for rejected vial. Tray collection of half stoppered vial. You can see the stopper over the vial in this area. Sliding conveyor for main movement before tray collection. these are the vials which are localized. This is a short description of the automatic injectable liquid filling line. After that, we will discuss the sterile product formulation, how it is formulated. There are different APIs, which will be one or more APIs, active pharmaceutical ingredient, and different vehicles are used. Vehicles may be aqueous vehicles or non-aqueous vehicles. The aqueous vehicles containing water for injection, UHT, water for injection free from carbon monoxide, that is used for the barbiturates and sulfonamides, and sterile water for injection USP, bacteriostatic water for injection USP, sodium chloride injection USP, bacteriostatic sodium chloride injection USP, moringa injection USP, and lactated Ringer's injection USP. These are the different classes of types of the aqueous vehicles, which are aqueous in nature. And on the other hand, the non-aqueous vehicles, example include fixed trials, ethyl alcohol, propylene glycol, and PEG, that is polyethylene glycol. These are the example of the non-aqueous vehicles. And for the vehicles, the formulation ingredients are from the added substances that are from the aqueous or non-aqueous vehicle, and APIs, including the solubilizing agent like surfactant, polysulfate AT, twins, different types of the twins, stabilizer, including the antioxidants, ascorbic acid, sodium bisulfite, sodium metabisulfite, and buffering agents, that is including the acetates, citrates, and phosphates. These are buffering agents which resist change in pH, antibacterial agents which control the microbial contamination, for example pisol, chlorpisol, and benzalkonium chloride. Tonicity contributor, as you know that it should be isotonic, and sodium chloride, dichrose, and boric acid are used as tonicity contributor. It should be equivalent to 0.9% sodium chloride equivalency should be there, that is termed as isotonic. And chelating agent, for example EDTA, that is ethylene diamine tetraacetate. Suspending agents, which is used in suspension formulation, whether dry suspension or in other suspension formulated, including methyl cellulose MC or CMC, carboxymethyl cellulose, gelatin, and acacia. And emulsifying agents, including the example of lecithin, and there are certain other emulsifying agents which are used in the formulation of the emulsion. That is an overview of the sterile product formulation. In short, we can say that it is categorized into API, it may be one or more, and vehicles, which may be aqueous vehicles or non-aqueous vehicles. Aqueous vehicles include the examples as I have told you, and yellow color, and after that the non-aqueous and aqueous vehicle. Well, the aqueous vehicle is yellow colored, and the non-aqueous vehicle which are green color, and added substances are there which are colored different, that is the blue color, which may be classified for your convenience into three APIs and vehicles, which may be aqueous or non-aqueous, added substances, and these are the added substances in the formulation of sterile products. After that, you can see the detail of these. The added substances added to a product to enhance its stability are essential for almost every product. Some of these details are solubilizing agents, they are termed as wetting agent. Solubilization is the increase in solubility of a poorly water soluble substances with surface active agents. An example include lecithin and apart from lecithin, polysorbates, including the polysorbate AT, which is a popular one, widely used as surfactants for propylene glycols, and there are several other solubilizing agents or wetting agents which are used to enhance the solubility of the poorly water soluble drug. The second class of the added substances that is termed as antioxidants. Many drugs and aqueous solutions are easily degraded by the oxidation, and when they are exposed to oxidation, their degradation occurs, their stability will be deteriorated. Small volume parental products of these drugs often contain an oxidant and antioxidant. Examples include bisulfides and metazol bisulfite, sodium metabisulfite, and sodium bisulfides are commonly used. Antioxidant and aqueous injections. Antioxidant must be carefully selected for use in injectables to avoid interaction with the drug. Remember that any other additives except from the API it should be also selected according to the interaction, the basis of interaction. If there is any type of interaction, which may be with API with other API or API with the rest of the formula ingredients, that is the details, then it is rejected. Care should be taken in selection of the any details or any excipients to avoid any interaction with the drug or with the other excipient used in the formula. Antioxidants have a lower oxidation potential than the drug and are either preferentially oxidize or block oxidative chain reaction. And by this way, the products are stabilized and oxidation is avoided because the oxidative chain reactions are blocked or the drug has lower oxidation potential by using the suitable antioxidant which is compatible with the active pharmaceutical ingredients as well as with the rest of the excipient of the formulation. Another additive substances that is termed as buffering agent. As you know that buffers are those substances which are added to change resistance. The pH, the ideal pH of parental products is pH 7.4. If the pH is pH 9, tissue necrosis may result. It is necessary to maintain the ideal pH. If the pH is increased, the tissue necrosis has resulted, while if the pH is below pH 3, pain and phlebitis and tissues can occur. So the pH above 9 is dangerous and the pH below 3 is dangerous, and pH below above 9 then tissue necrosis occur, and if the pH is below pH 3 then the pain and phlebitis of tissue and the tissues occur. Buffers are included and injections to maintain the pH of the packaged product. The pH changes can arise, interaction between the product and the container, and it is necessary to add the buffering agent which stabilize the maintain the pH of the formulation. Acetate, citrate, and phosphate buffers are commonly used in the parenteral formulation in order to maintain the pH of the formulation. It is evident from the discussion that buffering agent is very much essential for the formulation of these sterile products because pH above 9 results the tissue necrosis, and pH below 3 which results pain and phlebitis in tissues, which resulted not maintaining the pH. That's why buffering agents are added. An example of buffer agents include acetate, citrate, and phosphate buffers, which are commonly used in the parenteral product formulation. Antibacterial agents are also added in the formulation of the sterile products. Antibacterial agents may be divided into two groups according to the speed of action and residue production. And the first group that contains those antibacterial agents that act rapidly to destroy bacteria. This is the first group, and but quickly disappear. Example include alcohols, chlorine, peroxide, and aldehyde. These are the types of the antibacterial which are responsible for rapidly destroying bacteria. The second class of the antibacterial agent consists of mostly newer compounds that do long-acting residue on the surface of the which is disinfected and thus have prolonged action. For example, trichlocarbon, and sodium chloride. These are the second class of long-acting residue containing compounds. These are the two main classes of the antibacterial agents which are used in the formulation of the sterile. Toxicity contributors, sterile products are required to acetonic with the blood serum or any other body fluid. Some of the commonly used toxicity contributors are sodium chloride and borax. As an example of commonly used toxicity contributor can be sterile product manufacturing. Another agent that is termed is chelating agents. These are also used in the pharmaceutical sterile products, which are added to complex and thereby inactivate metals such as copper, iron, or zinc, which are generally catalyze oxidation of the drug molecules. So the copper, iron, or zinc like the metals are inactivated by adding the agent from the chelating agent, which inactivate the metals. And sources of metal combination include raw material impurities, solvents such as water, rubber stoppers, and containers and equipment employed in the manufacturing process. These are the sources of the metal contamination which is responsible for different chelating agents are used in order to inactivate the metal. And rarities and impurities, solvents, and water, rubber, proper, and containers and equipment. We have complied in the manufacturing process of sterile formulation, and purified certain metals resulted like copper, iron, or zinc. The example of chelating agents include ADTA, that is ethylene diamine tetraacetate, which are used as chelating agent. Suspending agents, as you know, that is responsible for products with suspension or the reverse suspension or the formulated suspension, body suspension for use, and the sterile products. Suspending agents are necessary. A suspending agent is a liquid in which a solid can be held in suspension. The drug is held in the suspension by a suspending agent and does not settle at the body. The tablet is dissolved in suspending agent. This will help suspend any insoluble component in the liquid. We have studied in the suspension about the suspending agent, that why suspending agents are added, and what is the role of suspending agent in the formulation of suspension. If the product of the drug is not soluble, in order to provide or deliver the drug which are insoluble particles, it is a convenient way to suspend it using a suitable suspending agent and provide insoluble components in the suspension form in a liquid, a suitable liquid or liquid. Example of suspending agents include MC, in short is abbreviated as MC, that is methyl cellulose, gelatin, and CMC, that is carboxy methyl cellulose, or sodium CMC, that is cellulose. These are the cellulose derivatives. These are the popular examples. They are widely used as suspending agent in the sterile product formulation. Emulsifying agents, in case of the emulsion formulation, emulsifying agents are used, which is used for the immiscible liquids, or they are to reduce the interfacial tension between the two immiscible liquids. One phase is because chlorine and small droplets. The form of small droplets are used, and it is necessary to disperse the globules or droplets uniformly in another. In this case, the emulsifying agents are used in order to stabilize the two non-blendable or immiscible liquids. Example of emulsifying agents which reduce the interfacial tension between the two immiscible liquids. Two immiscible liquid example include oil and water. If you want to mix water and oil, it is not blendable when you come with immiscible liquid. And the example of emulsifying agents are PEG, that is polyethylene glycol, and DCP. These are the example of emulsifying agents. Depends. You can consult theory and practice of industrial formulation, 3rd edition, by Leckman and H.L. Lieberman, J.L. Koenig. That's all about the today topic. Let's overview the topic. And the today topic we have discussed the plastic and glass used as containers in the sterile products. And after that we have discussed the formulation of the sterile products. What is the formulation ingredients? Before discussion of the plastic and glass container, we have discussed in detail about the packaging and what is meant by packaging, the definition of packaging, the collection of different components, and the different components include the bottle, vial, product, caps, tube, and blister, etc. These components surround the pharmaceutical product when it is manufactured, after the manufacturing, after time of manufacturing, until it's used. The products, that is the pharmaceutical product, is surrounded by the components. Collect and combine these components, and then it is formed as packaging. After definition of packaging, we have discussed the different types of packaging material. What is primary packaging, and what is the example of primary packaging, what is secondary packaging. The primary packaging, a simple word, is dead packaging. The first envelopes the product. In this primary packaging, the package is in direct contact with the contents or material of the formulation. The secondary packaging, it is outside primary packaging, and perhaps it is used to group primary package together. And the tertiary packaging, that is outside the secondary packaging, it is used for the bulk handling, warehouse storage, and transport shipping. The most common type is form is pelletized unit load, that packs tightly into container. After the packaging, different types of packaging, we have discussed the filling of packaging, plastic and glass containers. In that particular discussion, we have studied the pressure pump filler and vacuum filling, and how vacuum filling and how pressure pump filling is done. Pressure pump filling, as the name indicates, it is based on the pressure, and the liquid is filled under the pressure. When in the vacuum filling, vacuum is applied, vacuum is produced in a bottle, and by the mechanism of vacuum, the filling is done. We also discussed the filling equipment for solids, and how solids are filled, packaging of sterile products, different types of material composition of the packaging, including the glass, metals, rubbers, and plastics, composition of the packaging as well. After that, we have discussed the formulation of the sterile products, that is classified as API, which is more and more, which is responsible for the therapeutic efficacy or therapeutic activity of the drug or dosage form. Vehicle may be aqueous vehicles and non-aqueous vehicles. We have discussed in detail the example, what are the different types of aqueous vehicles are there and non-aqueous vehicles, and the added substances, and we have discussed in detail about the added substances one by one. Along with the example. And finally, I have told you about the reference, that is the theory and practice of industrial pharmacy, third edition. Inshallah, we will discuss this topic in the online Google Meet class as per the prescribed time. timetable. Thank you all for your attention. Dear students, you can see overview this topic in the book that is already uploaded on the portal. It is labor in the theory and practice of industrial pharmacy. You can see chapter number 22, Sterile Products, pages 639. If you visit pages 639. Start of the chapter, you see over there this book you can see the topic, the different editors used in the formulation of sterile products. You can see there is sterilization or after the sterilization, chapter number 22. Thanks for chapter number 22. The details, a variety of ingredients that will be added to formulation to provide required stability. You can see over there details, different types of editors. It is complexing agent, oscillating agent, which is mentioned in the formulation. And you can see that the role of pH. Upon a previous solution undergoes summarization or oxidation, but if its pH is maintained, the clear lower lateral reaction occurs. That is the role of the pH. The buffering agents used in the formulation. Different composition of the fuels types, type 1, 2, 3, and third is over there, glass container, the plastic container, and tonicity contributors, buffers, the detail, and the concentration of the excipient that is used, with the range of the concentration used as excipient. And you can see over the table it is solubilizer, wetting agent or emulsifier, and buffers added, bulking substances or tonicity modifier, suspending agent, chelating agent, stabilizer. These are the different editors, solubilizer, antimicrobial preservatives, which are commonly used for commercial parent food products. These are the added substances. And the solvents we have studied, that is either the aqueous solvent or non-aqueous solvent. you can consult over the pages, that is page number 639 onward. Thank you all for your attention.